Hello friends, myself Dongre Shital Suresh from Rajarshi Shahu Mahavidyalaya Latur, class MSc Chemistry, first year, same first. Today we will discuss some points about microstates. First we see the introduction. The number of microstates of a system corresponding to distinct arrangements of number of electrons to be in n number of possible orbital positions in level. Microstate is the possible arrangement of electrons in orbitals. Now we will see the definition of microstates. Each specific way, each arrangement of the energy of each molecule in the whole system at one instant is called as microstate. And each different arrangement of electron in set of orbital has slightly different energy is called as microstate. It is also used to determine the angular momentum and spin multiplicity. Now we will see the how will we calculate the microstate of a system. The number of microstate or degeneracy, which is represented by capital D, can be calculated by using formula. Capital D is equals to capital N factorial divided by capital N minus small r whole factorial into small r factorial, where capital N is the total number of occupancy or capacity of electron in orbit, or n is nothing but twice the number of orbitals. We know that orbital S has one orbital. Therefore, for this calculation, that is microstate calculation, we have capital N is twice the number of orbitals. Therefore, multiplied by 1 get 2. 1 is for S orbital. For calculation microstates, capital N is nothing but 2, where small r is nothing but number of electrons. Where n factorial is equals to small n into n minus 1 into n minus 2 up to 1. म्हणजेच n फॅक्टोरियल इज इक्वल्स टू n मायनस 1 इंटू n मायनस 2 अप टू 1, म्हणजे 1 येईपर्यंत त्या n संख्येचा गुणाकार करायचा, त्यामधून 1 मायनस 2 मायनस करून. फॉर एक्झाम्पल वी विल सी द फर्स्ट एक्झाम्पल. 3 फॅक्टोरियल इज इक्वल्स टू 3 इंटू 3 मायनस 1 इंटू 3 मायनस 2 फॅक्टोरियल इज इक्वल्स टू 3 into 3 minus 1 into 2 is equals to 2, and into 3 minus 2 is equals to 1 is equals to 6. Therefore, for 3 factorial we get the factorial number is 6. Now we will calculate the microstates for different systems. Calculate the number of microstates or degeneracy for the following configurations. For P1 configuration or system, we know the number of microstates is equals to capital N factorial divided by n minus r whole factorial into r factorial. In this P1 configuration or system, capital N is nothing but 6. Therefore, D is equals to 6 factorial divided by 6 minus 1 whole factorial into 1 factorial is equals to 6 factorial 6 into 5 factorial divided by 6 minus 1 is equals to 5. That is 5 factorial into 1, because we know that the 1 factorial is equals to 1. Therefore this 5 factorial and this 5 factorial get cancelled, and number of microstates for P1 system is equals to 6. Now we will see the number of microstates for D1 configuration or system. We know the formula for number of microstates is equals to capital N factorial divided by N minus R whole factorial into R factorial. Here capital N is nothing but 10 for D1 system. Therefore D is equals to 10 factorial divided by 10 minus 1 whole factorial into 1 factorial. 10 into 9 factorial divided by 10 minus 1 is equals to 9 factorial into 1. This 9 factorial will cancel. For D1 configuration, the number of systems we will get 10. Now we will see the number of microstates for mixed type of system. First we see the number of microstates or degeneracy for P1D1 configuration or system. Here we know that the formula for number of microstates, that is capital N factorial divided by N minus R whole factorial into R factorial. Here mixed type of system is present. Therefore here we take the two formulas. One is for P1 and other second is for D1. And after that we calculate number of microstates for P1 and D1. It is calculated also by separately, that is above that. In above examples we will see how calculate the number of microstate for one system. Here we calculate number of microstates for P1 firstly. Therefore D is equals to, for we know that N is 6 for P1 system. Therefore N factorial divided by 6 minus 1 into whole factorial into 1 factorial. We will see this calculation above is become 6. Before that we will see this calculation in above examples. So now we will calculate the D for D1 system is equals to 10 factorial divided by 10 minus 1 whole factorial into R factorial is equals to 10 into 9 factorial divided by 10 minus 10 minus 1 is equals to 9 factorial into 1. This 9 factorial get cancelled, is equals to 10 factorial. For D1 configuration, number of microstates gets 10. For P1 system, number of microstates are 6, and for D1 system number of microstates are 10. Therefore for multiplying 6 into 10 getting 6. Therefore for mixed type of system P1 D1 system or configuration, the number of microstates will be 60. Now we see the example, another example. We calculate the number of microstates or degeneracy for T2G1 EG2 configuration. We know the formula for number of microstates. We calculate separately number of microstates for T2G. For T2G1 number of microstates is equals to 6 factorial divided by 6 minus 1 whole factorial into 1 factorial is equals to 6 into 5 factorial divided by 6 minus 1 is equals to 5. 5 factorial into 1. This 5 factorial by factorial get cancelled. For T2G1 system, D is equals to 6. And now we will see the uh, degeneracy for EG2 system. Therefore, D is equals to 4 factorial divided by 4 minus 2 factorial into 2 factorial is equals to 4 factorial is equals to 4 into 3 into 2 into 1 divided by 4 minus 2 into 2, that is 2 factorial is equals to 2 into 1 is equals 2 factorial is equals to 2 into 1. This 2 get cancelled. 2 1s are 2 2 2s are 4. Therefore, for EG2 number of microstates gets 6. Now we will combine these two number of microstates, that we will get, it is D is equals to 6. This 6 is for number of microstates for T2G orbitals, and this 6 number of factorials for EG2 system is equals to 6 into 6, that is 36. Therefore, for T2G1 EG2 configuration, the number of microstates will be 36. Thank you.